Hello, we are Team Safe, and we are Shreyas, Sunkyu, and Mia. We chose the level axolotl because we do not have any experience with using photons or microcontrollers, and this was a good experience for us to learn C++. So what is our project about? We created this project because as Berkeley students, we constantly receive messages from the Berkeley WARMI systems of any potential hazards or crimes that happen around us. Most people would just shrug off the information, believing it is irrelevant to them or it could reach them late, and they would just disregard its seriousness. The exact location of the event is often forgotten or ignored, which could render the WARMI system useless. So what we propose is a wearable device. Basically, we designed a physical system that alerts the students when they are near or in contact with a WARMI zone. Zones are detected using a gunshot, gas leakage, and buttons which give coordinates of a potential zone. LEDs and vibrating motors let the user know of it that they are close proximity to the location. So there are 3 stages: when it is safe, when it is close, and when it needs any warning messages. So about the system, we have 3 inputs and 2 outputs, and the cloud interacts with the Photon 2 through Wi-Fi connections, and they give responses as inputs and outputs. Our prototyping process looks like this. We connected the Photon 2 with the Stemma QT, and also to the switches with caps, RGB LED lights, the DRV2605L haptic motor controller board, a vibrating mini motor, and the BME 688, which detects temperature and gas and humidity. So the red alert system will happen when there is a gas leakage, or when there is a gunshot, or when there is a theft or robbery happening around you. As you can see in the demo video, when there is a gunshot or whenever there is a fire hazard happening around you, then the light will turn to red. Whenever you are entering an unsafe zone, that is detectable by the blue LED color, as shown in our demo video. And once that happens, and when students are far away from the hazards, then the light turns to green, which means that they are safe now. There were many challenges while doing this project. Our first challenge was combining the data from diverse sensors while ensuring that they work together seamlessly. Another challenge was that the BME 688 sensors, gas readings, and loudness sensor data can fluctuate due to changing environmental conditions. Also, setting up secure and reliable communication between the Photon 2 and Google Maps API through the particle cloud was also quite difficult. And finally, the gas sensor had trouble accurately detecting nearby alcohol levels, which was why we changed it to detect temperature levels. Individual challenges for Shreyas, it was difficult to implement GPS location protocols so that photons can communicate with each other and work with different sensors together. And also it was difficult to merge the code for different sensors without breaking the initial functions. For Mia, she had no experience of microcontrollers and coding before. The integration of the vibration motor and the RGB LED were challenges for her. Ensuring that both components operated smoothly together without interference required precise control of timing. And as for me, Sunkyu, I had no knowledge of C++, so I had to start from nothing to create a working algorithm that uses loudness sensors and gas temperature humidity sensors that functions in sync with the components that my other teammates came up with. For speculation, I believe that we can create our custom hardware by miniaturizing components and cutting down physical sizes, and also we could eliminate the breadboard. We can also 3D print a case for the device for easier wearable equipment in the form of a necklace or cloth pin. Adding Edge ML functions to detect gunshot sounds from other loud noises is also an upgrade, as well as introducing LLM agents that can automatically accept calls and pinpoint WARMI locations to add to the system. To sum up, the WARMI zone alert system successfully detects hazardous areas using gunshot, gas leak sensors, and a manual alert button, providing real-time danger coordinates. LEDs and vibrating motors serve as clear, effective indicators to alert students when they are near or inside a danger zone. And yeah, this design enhances student safety by offering a practical, responsive solution. So we each built 3 devices that all connect to each other and respond to each other. That was us. Thank you.